In Lesson 3.3, we're going to work on the application of interpreting remainders when we divide. You will need your whiteboard marker, and your math journal. Let's go ahead with a warm-up. Go ahead and number 1 to 3 on your whiteboard. And you're going to write the answer for how many 3s are in 21, how many 3s are in 210, and how many 3s are in 2,100. Go ahead, pause the video, and write your answer. So how many 3s are in 21? It's a basic fact. 3 times 7 is 21. So how many 3s are in 210? We'll just add 1 0 behind it. And how many 3s are in 2,100? Still 7 with 2 zeros behind it, 700. All right, erase your whiteboard and number 1 to 3 again. How many 7s are in 490? How many 70s are in 4,900? Be careful of that. Remember how zeros cancel each other out. And how many 700s are in 49,000? Pause your video and write down the answer. Well, how many 7s are in 49? There's 7, and then add 1 0 behind it, so 70. This 0 cancels out one of these zeros. How many 7s are in 49? 7, and 1 0 behind it. So make sure you get those math facts memorized. These 2 zeros cancel out 2 zeros here. We add in 1 0, 70. All right, one last warm-up like this. How many 80s are in 48,000? How many 800s are in 48,000? And how many 80s would we find in 480,000? Go ahead, pause your video, and answer these 3 questions. Well, for number 1, this 0 cancels out this 0. How many 8s are in 48? Well, there's 6 with 2 zeros behind it. These 2 zeros cancel out these 2 zeros. How many 8s are in 48? 6 with 1 0. Let me just show you if I took 800 times 60. 8 times 6 is 48 with 1, 2, 3 zeros. 1, 2, 3 zeros. Brings me back to this. This 0 cancels out this one. There are 6 8s in 48 with 1, 2, 3 zeros behind it, so 6,000. All right, go ahead and wipe off your whiteboard. We're still going to stay on our whiteboard for a little bit. Mr. Bergener has 30 yards of masking tape for a tower building contest. There are 7 teams, and each team needs as much tape as possible to build the tallest tower. Anna says that each team should get 4 yards of tape because 30 divided by 7 is 4 with a remainder of 2. Do you agree that the remainder should be ignored? Why or why not? Well, I do not think that should be ignored because this tells me that there are 2 yards of tape remaining. There are 7 teams, so they don't each get a whole nother yard. But if I took that 2 yards of masking tape, I could say 1, 2, 3, 4, 5, 6. I could divide it into 1/7, 1/7 of here, 1/7. And you know what? I could give each team at that. I don't want to ignore it. They want as much tape as possible. So they would get 2 7s of a yard each team. So sometimes we ignore the remainder, and sometimes we report it as a fraction if we can divide it up. So when you think about whether or not to report a remainder as a fraction, I want you to think of when you report it as a fraction and when you would ignore it. Let's say you're dividing up things like pizza or a granola bar or a candy bar or an apple. Those are all things that I could report as a fraction. I can divide an apple in half or in thirds. I can divide a granola bar into fifths. So if you're sharing or portioning food, I want you to write that remainder as a fraction. Let's say you're dividing pounds of clay or buckets of sand. Can you divide a bucket of sand in half or into a third or a fourth? Absolutely. So that is another time you would report the remainder as a fraction. What about if you were dividing up people, animals, phones, or pencils into a group? Would that make sense to divide that into fractions? Well, you wouldn't say half of a teacher or a third of a phone or a fourth of a pencil. So in that case, we would just ignore the remainder. It wouldn't make sense to report that as a fraction. Let's imagine we're converting measurements into smaller unit to a large unit, such as converting 20 inches to feet. So here we would want to report. I could say a half of a yard or 1/4 of a mile. So that makes sense to report that as a fraction. So keep that in mind. If it makes sense that you can divide up something into smaller parts, report that remainder as a fraction. So again, continuing on our whiteboard, we're going to practice this. Ben just adopted a dog. The veterinarian said a bag of dog food should last 14 days. The bag contains 21 cups of food. If Ben feeds his dog the same amount each day, how many cups of food should he feed the dog? The first thing we're going to do is we're going to go ahead on your whiteboard and write 21 divided by 14. So what we're going to do then is we're going to say how many times does 14 go into 21? Well, it goes in there once, and all I have to do is subtract. You can do this with me on your whiteboard. Remainder 7. Okay, now we're not focusing so much on the division today, so you'll see the division is fairly simple. We're reporting and looking at what that fraction means. Should he just take that 7 cups of food and throw it away or ignore it? No, absolutely not. He has to divide that up into a smaller fraction. So what we would do then, remember, the divisor always is our denominator. So the answer would be 1. We're going to write this as a fraction. The remainder goes on top. The divisor goes on the bottom. So the dog would get 1 7/14 of a cup. Does anyone know a different way to say 7/14? What's half of 14? 7. So another way that you could say this would be 1.5 cups. Typically, we wouldn't say, oh, give the dog 1 7/14 of a cup, but we would say, give the dog 1.5 cups of food. So in this case, we don't want to ignore the 7 cups of food that remain. Let's try another one. Erase your whiteboard, and I want you to write what I'm writing. There are 35 mini bags of pretzels for the 20 students in the after-school program. To avoid wasting the leftovers, the students agreed to equally split any remaining bags. How many bags of pretzels will each student receive? So would you please write 35 divided by 20. Write that in your whiteboard. So what that tells me is I have to take and divide 35 by 20. How many 20s are in 35? Well, it goes just once. I subtract. There's 15 bags that remain. What this tells me is every student will get one bag. The remainder is 15. We don't want to just set those 15 bags of pretzels aside and say forget it. So we're going to write it as a remainder, as a fractional remainder. So the remainder goes on the top, the numerator, and the divisor always goes on the bottom. So what we would say is that each student gets 1 15/20 of a bag of pretzels. So we don't want to ignore that remainder. We want to take those bags that remain, the 15 bags, and divide them up. Let's go ahead and take a look at similar problems in your math journal. So you're going to turn to journal page 77. And again, these are very easy division problems so that we can focus our attention on what to do with the remainder and not so much focusing on the division part of it. So on page 77, it says division number stories with remainders. For each number story, we're going to write a number model with a letter for the unknown, which is called the variable. We're going to solve. We're going to show our work in the space provided. We may end up drawing a picture to help us. And then we're going to decide what to do with the remainder. So that's the important focus of today, is what do we do with the remainder? Number 1, Rebecca and her 2 sisters made pancakes for breakfast. They made 16 pancakes for 5 people. They want to make sure that each person gets an equal serving. How many pancakes will each student or each person get? So we're going to take those 16 pancakes, divide it by 5 people, and we're going to put a variable. That is a lowercase letter, not an uppercase, but lowercase letter that represents what we're solving for. It can be any letter of the alphabet. I'm going to put P for pancakes. So I'm going to say, let's take those 16 pancakes, divide it by 5. So we're just asking ourselves, how many 5s are there in 16? Well, 5 times 1 is 5. 5 times... You don't have to write this part down. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. That's too many, so it goes in there 3 times. So it's just a basic fact. It goes in there 3 times. Then 5 times 3 is 15. There's 1 pancake that remains, so we're going to take that 1 pancake. Please draw this picture. We're going to divide it into 5 equal parts. What we're going to do with that pancake that remains is we're going to divide it into fractions. So the answer is 3. And then we take that last pancake, that's the remaining pancake, and each person will get 1/5 of the pancake. Remember, the remainder is written on top, the divisor is our denominator. So at the bottom, we're going to write the quotient is 3, they each get 3 pancakes. The remainder was 1, so we're going to take that remainder and write it as a fraction. Each person will get, let's go back, each person will get 1 out of 5 pieces. Whoops. Each person will get 1/5. Circle what we did with the remainder. We either ignored it, no, because we don't want to throw that pancake away. We reported it as a fraction. The other option is we can round up the quotient. We could round this up to 4, but there's not enough pancakes. We can't round that up to 4. That doesn't make sense. Why did we report as a fraction? Because pancakes can be cut into smaller pieces. Remember to pause the video if you need additional time. Let's go back to question number 2. Lewis's soccer team is taking a bus to a tournament. They have 32, and I would circle that. I would get into the habit of circling important information. 32 reusable bottles. Their water carriers hold 6 bottles each. How many carriers will Luis's team need to bring all of their water bottles on the bus? Remember that they don't want to leave any water bottles behind, okay? So the number model would be 32 divided by the 6 bottles that each carrier holds, and then we need a variable. I'm going to put W for water, to lowercase w. Now we're going to say, how many 6s are there in 32? Again, they're making this a really easy division problem. So 6 times what would get me closest to 32? Well, you don't have to write this down, but here's my thinking. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. And 6 times 6 is 36, which is too much. So it goes in there 5 times. So all I'm doing is showing you my thinking. So 6 times 5 is 30. Go ahead and subtract. Right now, this tells me that there are 2 water bottles that are not in a water carrier. Okay, so let's go to the bottom of the page. Our quotient was 5. Our remainder was 2. There's 2 water bottles not in a carrier. How many carriers does Luis's team need so that all of their water bottles are in a carrier? So in this case, 5 wouldn't be enough. I need to round up to 6. So what did I do with the remainder? Did I ignore those 2 water bottles? Did I say I need 2/6 or 2/5 of a carrier? Well, you can't cut up. I'm guessing these are like metal or plastic carriers. You can't cut that up into smaller parts. Or did I round the quotient up? The quotient is the answer when you divide. I rounded the quotient up. So they need another carrier. All right, let's continue on to page 78. Page 78. Mariana saved $80, circle that, from her babysitting job. She wants to buy some shirts and pants that are on sale at her favorite store for $17 each. Circle 17. How many items of clothing can she buy? The number model would be $80 divided by $17 per item. And I'm going to put C for clothing. It's a lowercase letter to represent the variable, what we're solving for. So let's go ahead and put 80 in the dividend. And we're going to divide that by $17 per item of clothing. How many times does 17 go into 80? Well, the easy way to do is just double the number. So I'm going to say it goes in at least 2 times. 17 plus 17 is 34. I can do that in my head. So go ahead and subtract. Show me your work in your math journal. You should be doing this with me. Ten minus 4 is 6. 7 minus 3 is 4. Can it go in 2 more times? Absolutely. We know that 17 doubled, or 17 times 2 is 34. Can it go in there even 1 more time? No, it cannot. As long as my remainder is smaller than my divisor, I'm done. So the answer is 2 plus 2, which is 4, with a remainder of $12. Now let's go to the bottom of that page. The quotient, it said that she could buy 4 pieces of clothing and the remainder was 12, which means $12. So how many items can she buy? Can she go to Target and say, can I just buy half of that shirt or a third of those pair of pants? Absolutely not. She can buy 4 items. We ignored the remainder because she doesn't have enough money to buy more. Again, remember, if you ever need more time, that's the beauty of video. Put it on pause. And just for the sake of time, we are not going to do the last one.